Hi, so I'm Ben. I work for ASI Data Science. Now, ASI Data Science is specifically a firm designed to help companies exploit AI in the real world. Now, one of the things that I think when I talk about AI, artificial intelligence, I'm really just talking about getting a computer to do something that if a human did it, we would call it intelligent. Now, that might be something simple like, is this picture a sunset or a table or a chair? Or it could be something more complicated like playing chess, for instance. Now, if we just look at the game space, and a couple of months ago, Google's AlphaZero beat the best human Go player in the world for the first time ever. And that's interesting for two reasons. It's interesting for the first thing is that means that computers are now better than humans at every single game we have ever invented. And this really shows how computers are unbelievably powerful. Also, the interesting thing is that computer never interacted with a human. It wasn't trained on human games, it didn't learn from humans. It simply played against itself and in 3 days became better than humans had become in 3,000 years of playing Go. So some of these AI projects are really advanced, really complicated. So for instance, at ASI we work at this edge. Like for instance, we're currently working with the Home Office in building these sort of deep learning models that Ben talked about to identify extremist propaganda and bring it down. And this does involve lots of people with large-scale computation and the most complicated techniques. However, today I don't want to talk to you about this sort of cutting edge of AI, but I really want to talk about much more practical AI applications that smaller businesses, or businesses you wouldn't necessarily expect to be using AI, are actually using in their day-to-day lives. So the first organisation I'd like to talk about is actually the London Fire Brigade. Now, the London Fire Brigade is actually a fantastic organisation at using analytics. In fact, the number of deaths from fire in London have dropped dramatically over the last 30 years. And that's really due to the London Fire Brigade really going through data, producing analytics, and then bringing in preventive measures. For instance, we all go through fire marshal training, we all see fire doors. These are all due to the analytics that show these reduced deaths. Now, the way this information comes in is after every fire, there's a fire inspector will fill in a questionnaire. And this questionnaire is about 70 multiple choice answers. And then if it's a more serious fire, they write a report. Now, these reports can be quite lengthy, and there are actually quite a lot of fires in London. So to give a perspective, since 2010, we're talking about 37,000 pages worth of fire reports. So if I started reading that today, I'd probably get to the end about this time next year. So as you can imagine, that's really, in fact, a human just can't interact with that data. We know that data is inherently valuable. These are the most serious fires, but we can't get access to that data. So what ASI did in collaboration with the London Fire Brigade is we trained a model, so a natural language processing model, which is designed to pull out information from text, to take these reports and put them into different topics. Now, some of those topics are the ones you would expect: electrical cooking, electrical fires, cooking, and in these topics we see they go down over time. However, for one topic we actually saw them increasing over time, and when we looked more into this topic we saw that this was associated with restaurants and fats. And actually what was happening is that restaurants, fat was getting into the ducting, setting on fire. These are actually quite dangerous fires because, as you can imagine, they're quite difficult to put out. Now, the most amazing thing is, not only can we track these in time, but we can also look at where these fires occurred in geographical space. And what we saw is a cluster around Edgware Road and a cluster around Chinatown. So now the London Fire Brigade can actually bring in preemptive inspections, and they're going out to these restaurants and preemptively inspecting in order to cut down the number of fires in this area. So this is a good example of where AI is a complementary thing, where it's actually used to gain information we otherwise couldn't exist in. Now, I'm sure nobody in this audience is actually putting out literal fires in their day-to-day work, but everyone will be trying to get hold of more customers. Now, trying to attract customers is very expensive, very difficult. Now, you can imagine if you put yourself in the place of Rolls-Royce cars, this is even more difficult. The Phantom cost $350,000, so finding one person who can afford that car is difficult enough, let alone trying to find somebody who wants to pay that much for a car. So Rolls-Royce obviously spend a lot of time interacting with their customers, trying to sell them more cars. And this involves a lot of work, relationships, building relationships over time, inviting people to events. Like, for instance, if you're having a launch event, who do you invite? Now, what Rolls-Royce realized is that for some of their cars owners, they're only ever going to buy one car. For some of them, they might be able to buy more. And now how do you find them? So what Rolls-Royce did is they simply took their data sets, they took their data from their interactions with their sales staff, with the dealerships, with when the people come in for servicing, for instance, their car usage, and they built a data set. And then what they did is they simply trained a machine learning model to classify which car owners own one car and which car owners own 2+ cars. Now this machine learning algorithm is actually really quite predictive. It's about 80% predictive of who owns 2 cars. But actually in this instance, the 80% isn't the interesting part. It's the 20%, the error in that machine learning model, that's really interesting, because these are the customers who own one car who are most like the customers who own multiple cars. So what Rolls-Royce did in their recent car launch is they decided to prioritize these 20% and to select them and prioritize them for launch events and such like. And this is actually, Rolls-Royce credit this with giving them millions of pounds of revenue. So this is a good example of how this could be applied to every business. But I'd also like to talk about how actually you can use AI to actually transform how you do a process or an industry, how you do a process or a workflow. And actually to do that, I'm not going to talk about business, I'm going to talk about charity. So we've all heard of Amnesty International. Now Amnesty International go out of their way, their whole mission is to try and stop human rights abuses around the world. And the way they do this is through media campaigns. Every day they release a lot of press releases to try and build press stories, and these press releases go out in different languages, to in different countries about different stories. And they produce a lot a day, about 5 a day. So you can imagine for Amnesty, it's crucial that they understand the impact of these stories. But this is a really difficult problem, right? This is multiple stories out there in the real world, in multiple languages across multiple countries. So the old process was simply this: a bit of Googling, building together a spreadsheet, trying to build this together, and then a bit of Excel analysis. And as you can imagine, that's a slow process. It takes about 6 weeks. It's also expensive in human time, but also, I would say, maybe prone to bias depending on who's doing that analysis, who's deciding that story's in or not. So what Amnesty International now have is actually an AI workflow. What happens is that every day an algorithm pulls in over 10,000 different articles from across the globe, and it compares each of those articles to the recent Amnesty International press releases and looks for similarities in sentences, in facts, in whether it mentions Amnesty International. And because this is an AI, it can happen in real time. So Amnesty International can now look at their dashboard and say, this story is going very well, this story is going bad. So that means that they can say, okay, we want to allocate more resources to this story, we want to add resources to this campaign, something that they had no ability to do before. So that shows how actually by a different AI workflows it can revolutionize. It allows you to actually understand the impact and make decisions in real time. The last example I'd like to use today is about scaling. Now, the company I'm going to talk about is Octopus Energy. Now, Octopus Energy is a fantastic company, and they are an energy supplier. And one of the reasons they are growing so quickly is because of their customer service. Rather than ringing up your energy supplier, dialing 1, pressing 2, pressing 3, frantically mashing the keypad to try and get through to a human operator, instead what they have is a simple system. You email hello@octopusenergy.com with whatever you want to do, and it gets put to the right team, or just sent to the right team. So for instance, if I email Octopus, I say to them, hi, I'm moving house, but I want to keep with you. Can you move my contract to a new address? It goes through to the right team. Now, the problem with this is that you can imagine if a human is doing it, it takes time. A human has to read it, make a decision, and send it to the right team. And this, A, causes a slower customer process, but more importantly, it affects scaling. When Octopus Energy was small, this is fine. They're now much bigger. They get 20,000 emails a month, and this is only going to grow. So what Octopus Energy now have is, rather than having a human do that triaging, sending the email to the right team, they actually have an AI system that when an email comes in, it reads that email, it reads and looks at that email saying, I want to keep my eye, I'm moving house, and automatically sends it to the right team. Even more cleverly built into this system is, if that email, say my email goes to the complaints department by accident, the complaints department can put it to the right department, but also that gets flagged up inside the model, allowing them to understand, the model to learn and become more accurate over time, allowing that triaging to occur. So this is an example of not only an AI system giving you a better service because it's much faster, but also allowing a company to scale where it otherwise couldn't. So these are good examples of how AI is used in small businesses for real-world impact. Now, you might be thinking to yourself, well, how can I do that in my business? What challenges will I face? And the three big issues that ASI has come across with companies when they're looking at this sort of stuff is data, people, and tooling. Now, the first one is data. This one's kind of obvious. You know, for the London Fire Brigade, we had those 37,000 documents. For Octopus, we had the emails. It's key that you have this data and it's accessible, but also if you're thinking about things like Rolls-Royce of matching records, it's key that those match records can be linked. Often there is one identifier in one database, another identifier in another database, and that matching problem is a key thing. As a sort of quick rule of thumb, if somebody is using the data in their day-to-day workflow, in my experience, that data is usually quite good quality. However, if it's just sort of stored away in a database and everyone says it's there, that means that the data is probably of lower quality and there might need some work to be done to sort that out. The next one is people. You know, we shouldn't get away, although we're talking about artificial intelligence systems, there's somebody who has to build these in the first place. Now, these people need mathematical ability. A lot of this is basic, is the maths. You also need to be able to code. All these systems are built in software. But thirdly, and most importantly, that we sometimes forget, is that these people need to be able to identify business problems and solve them. And that is a key facet that we sometimes miss when we're sort of trying to recruit this sort of person. But in your company, you probably have people like this who can at least help on those sort of initial forays into data science. For instance, in your BI team, you might have somebody who's got a maths, a physics, an engineering background, who has the ability to code and could help you in this, you know, sort of as you test the waters around this. The final one, and actually I think the one that most companies overlook, is the idea of is tooling. What often happens, if you had a designer turn up and you would probably look at getting them a high-end Mac, Photoshop, you wouldn't give them a Windows laptop and Paint. However, I often interact with data scientists who have an old 2-year-old laptop and they're like, what do I do? And I'm like, you're fucked. Like, there's just no way you can do this, right? It's fundamentally, you need the right tools. And this is a more complicated workflow. You need to be able to get the data in, you need to be able to model it, but then, most importantly, for data science to be useful, it has to be actionable. A brilliant model sitting on a laptop is no use to anyone. So an actionable in this case means, for instance, in Octopus Energy, an API, or for instance, in Amnesty, an app that people can interact with. And for that reason, you need to make sure they have the specialist tools. In fact, ASI Data Science we have built a tool called Sherlock ML to allow data scientists to work quicker and allow their results to be more actionable. So in conclusion, I hope what I've shown you here is, rather than this sort of view that small businesses aren't using, these are examples of small businesses that are using AI and having this real world impact that's really sort of changing how they do business. Thank you very much.